Alrighty, guys. So this is our first lesson for Geometry B. We're starting our quadrilaterals unit, and so we're going to talk about classifying quadrilaterals and using a couple of those properties from the definitions. You'll see what I mean. Okay. So before we get started, we need to define and give ourselves a picture of all of these types of quadrilaterals. So these are the ones that have specific names that go with them. Some of these should be familiar. We have a parallelogram, rhombus, rectangle, square, a kite, a trapezoid, and an isosceles trapezoid. Okay, so I'm going to give you all the definitions for these, and then we'll give ourselves a picture. Okay, so let's get started. So a parallelogram is a quadrilateral with two pairs of opposite parallel sides. All right, that's the definition. And if we draw a picture, the best way I know how to describe it is kind of make it look like a rectangle, but where like you knocked it over, if that makes any sense. Okay, and to signify we've got parallel, we're going to put these little arrows. So I'm going to put one arrow there and one arrow there. So as a geometry person, that tells me that this pair of sides are parallel, so they're going to run forever this way and they'll never touch. And then we can put two sets of arrows on the other side. And so that tells me that these two sides are parallel, so they're going to run this way and never touch. Okay? And before I get any further, let me mention that I'm making this video on a document camera, and so the way I'm having to write kind of blocks what you need to see. So if you need to, you can pause the video after I write something so you can write it down. Okay? Now, the next two we're going to talk about rhombus, rectangle, and square. They're all related to a parallelogram. So they have this definition also, but they also have something extra that goes with them. Okay? So a rhombus is a parallelogram with four congruent sides. Remember, congruent is kind of means like equal, and so all four sides of a rhombus are equal. So to draw it, we could draw kind of like a squarish thing, but knocked over. And then to signify congruent, we put little, I call them ticks, but these little marks. Okay, that tells us that all four sides are the exact same length. Okay, a rectangle is a parallelogram with four congruents. Not congruent, my bad, wrong word. It has four right angles. We all know what a right angle is. That means it's 90 degrees. And we all know what a rectangle looks like. And so to signify a right angle, we put those little boxes in the corner. Okay? Now a square. A square is kind of special. It's kind of a combination of these two, rhombus and rectangle. So it's a parallelogram with four congruent sides and four right angles. We all know what a square looks like. So put your congruent tick marks and then your four right angles. Okay? And the next three you might be not as familiar with. But a kite is a quadrilateral with two pairs of adjacent congruent sides and no opposite sides are congruent. That's kind of a weird definition to just to sit and think about. So let me draw the picture. Hopefully it makes more sense. So we all know a kite looks something like this. Okay. Now the word adjacent means the sides are next to each other. Okay. So what I'm actually going to do is the two shorter sides, I'm going to say they're congruent, and then the two longer sides, they're congruent to each other. So that's what the kite definition means. We've got two pairs of adjacent, so this side and this side are adjacent to each other, they're next to each other. And then this longer side and this longer side are adjacent, they're next to each other, they're congruent. And as far as the no opposite sides congruent thing, look at this side, and then opposite would be across to this one. They're not the same length, okay? If we did that, then we could say we're at a parallelogram. But we don't want that, so that's why we have that stipulation. Okay. Trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. One pair and one only. So we could draw something like this. Make the bottom a little longer and then do that. So I'm going to say that this is parallel to that. Okay. Only one pair of parallel sides. And if we have an isosceles trapezoid, we take it a step further. It's a trapezoid whose non-parallel opposite sides are congruent. And when we get to the actual trapezoid lesson, we'll know that those sides are called the legs. But anyway, if we draw an isosceles trapezoid, you're probably more familiar with the trapezoid being this shape. So that side is parallel to this side, and then that and that are congruent. Something like that. All right, that's all the definitions. So now what I want to give you is on the back, second page, I want to give you a diagram of how everybody's related. Okay, so at the top, we're going to start with our quadrilaterals, just all your basic four-sided shapes. And then from here, we branch off into three different groups. So the first group is no sides parallel. Okay, the only shape we talked about that had no parallel sides was a kite. So he's all over here by himself. Then we talk about one pair of parallel sides. That would be your trapezoid. Okay, then you can take it a step farther. Then you have one pair when the non-parallel sides are congruent, that would be your isosceles trapezoid. Okay, then we get into two pairs of parallel sides. The first one we talked about was the parallelogram. Then from here, we can split off even more. So we have four sides congruent. I'm going to abbreviate. That's your rhombus. when all four sides are the same length. When you have four right angles, that's when you get your rectangle. Then if you combine both of those attributes of congruent sides and right angles, then you get your square. Okay, that's just to show you how everybody's related. So the first generation, I guess you could say, would be the kites, trapezoids, and parallelograms. Then you can branch off from trapezoid to get your isosceles trapezoid. And then from parallelogram, you can break off to rhombus or rectangle, and then those two come together to make a square. Okay, now we're going to use those definitions and some other stuff to do some examples. All right. I'm going to try not to spend a whole lot of time on here because we're already at 11 minutes and I don't want the video to be too long and you lose interest or shut it off, okay? So, judging by appearance alone, classify each quadrilateral in as many ways as possible. So, A is right here. Obviously, it's a quad, so we start there. And just to give you an idea, what we're kind of doing is we're starting here, and then how far down this chain can we go? That's kind of what we're doing. Okay. So looking at appearance, that side's parallel, and that's parallel, which means I have two sets of parallel sides, which means I know this is a parallelogram. Right? And then if I wanted to break a ruler out and measure, I could, but by appearance, each individual side looks the same length. So I'm going to go ahead and call that a rhombus. I can't say rectangle or square because to me this doesn't look like a right angle. Okay, if it was looking more like 90, I would say square, rhombus, rectangle, and square. But I can't say that right now. All right, B. So this one, obviously it's a quad. And this time I only see this and this are parallel. That's one set of parallel sides, so that would be a trapezoid. Now, under trapezoid, the only other place I could go was to an isosceles trapezoid. To say isosceles, my non-parallel sides, which in this instance would be this side and this side, have to be the same length. And just looking at it, they don't look the same length. So I'm not going to say it's an isosceles. I'm just going to stop at trapezoid. Okay? Okay, that's the first thing you'll do. I'll give you some shapes that look just like this, and just by appearance, you tell me as many names as you can. Next thing we'll do be like a little, you're going to graph some points. It'll make a quadrilateral, and then you have to determine the most precise name. So this time, you want to go as far down the chain as you can. So if you can go all the way down to isosceles trapezoid, that'd be your final answer. If you can go all the way down to square, that'll be your final answer. You're going as far down as you can. Okay? So let's get these points on here. L is at 1, 2. M is 1, 2, 3, 1, 2, 3. N is at 5, 2, 1, 2, 3, 4, 5, 2. And then P is at 3, 1. All right, so we got L, M, N, P. Okay? I've kind of told you what you need to do here. So first thing we need to do is to find the slope of each side, because that will help us figure out if we've got a parallelogram, and then we can determine if it's a rectangle from there. Okay? So we're going to have to remember the slope formula between 2 points. So that's going to be m equals y2 minus y1 over x2 minus x1. Okay. So let's go between L and M. We're going to do the slope of this side. And since M was second, I'm going to start with M. So the M of Y, or the y of M is 3 minus the y of L, which is 2, over the x of M, subtract the x of L. All right? Well, that's simple enough to do in your head. 3 minus 2 is 1. 3 minus 1 is 2. So that slope is 1/2. But if you wanted to, you could use your calculator. And what I would do to type that in is I would hit the alpha y equals key and make me a fraction and just type that thing in. 3 subtract 2 on top, 3 subtract 1 on the bottom, and I get my half. Okay. Now let's find the slope between M and N. I'm going to write slope there so I know what we're doing. So start at N. The y of N is 2 minus the y of M, which is 3, over the x of N, which is 5. Subtract the x of M, which is 3. If you figure that out, you actually get negative 1/2. All right, let's do NP slope equals, start with P, the y of P, 1, subtract the y of N, which is 5. Nope, it's not 5. I can't read. It's 2. Over the x of P, which is 3, subtract the x of N, which is 5. You figure that out, you're going to get a positive 1/2. Now let's do PL slope equals. So I'm going to start with L. The y of L, 2, minus the y of P, 1, over the x of L, which is 1, subtract the x of P, which is 3. You figure that out, you get negative 1/2. All right? So look at what we've got here. We've got the slope of LM, which is this side. I'm going to write it over here so we can kind of see it. That slope is 1/2. It's kind of hard to see. Zoom in there. Whoa! I regret doing this now. There we go. There we go. All right, so the slope of LM is 1/2. We found the slope of MN to be negative 1/2. The slope of N to P was 1/2. And the slope of PL was negative 1/2. Okay. Let me see if I can zoom this back up without causing all kinds of problems. Okay. Okay, sorry about that. Now, look at this. Opposite sides are parallel because they have, remember, parallel lines have the same slope. So opposite sides have the same slope, so they're parallel. So we're going to say opposite sides are parallel. That's the parallel symbol. So we know that we have a parallelogram. Okay. Could it be a rectangle? So let's think about a rectangle. A rectangle's definition is it have to have 4 right angles. So each angle right here and right here, all those would have to be right there. all of that to be 90 degrees. So in order to make that, those two segments would have to be perpendicular. Okay? And if you remember from algebra and earlier in geometry, we talked about perpendicular slopes. Perpendicular slopes have negative reciprocals, which means like if this slope here was 1/2, then the corresponding one had to be -2. You got to flip the fraction over. Okay? We don't have that. So we have no slopes are not negative reciprocals, means we have no rectangle. Okay, but we still have to check something else because we could have a rhombus here, which means all four sides have to be the same length. Okay, so to find the same length, we're going to have to use the distance formula. If you don't remember that, it looks like this. Get it on here. Okay. I need to pull that up just a little bit. Oh, shoot. Okay. Sorry, I'm adjusting stuff as I go. All right, so we're going to use this formula 4 times. So let's find the distance from L to M. Now I have a trick to doing this so you don't freak yourself out. So draw yourself a big square root, and then, okay, a minute. We're going from L to M, so we're going to start with M, the x of M, which is 3, subtract the x of L, which is 1, and then square it, plus the y of M, which is 3, subtract the y of 2, or y of L, which is 2, and then square it. All right? Now, here's what I want you to do. All this stuff underneath the square root, I want you to type it in. So, kind of like this. I'm not typing the square root in, so I'm just going to type the stuff underneath. 3 minus 1 squared plus 3 minus 2 squared. So 5. I'm going to put my square root back, and then I got that whole mess underneath was 5. Okay? I think that's the easiest thing for you all to do, is just to do it that way. Let's look at MN. All right? So, started in, the x of n, subtract the x of m, plus, squared, plus the y of n, subtract the y of m squared. And if you type that in, 5 minus 3 squared plus 2 minus 3 squared, hey, you get 5 again. Okay? Let's do NP. So start at P. The x of P, subtract the x of N, all that squared, plus, open a parenthesis, the y of P, 1, subtract the y of N, close it squared, so then 3 minus 5 squared plus 1 minus 2 squared. We get 5 again. It's looking like a rhombus. We've got 3 sides congruent. Maybe the 4th one is, so let's check it. P to L. So start at L. The x of L, subtract the x of P. Then the y of L, subtract the y of P. And if you figure that again, hey, it's gonna be square root of 5 again. So we have all sides are congruent. That's the congruent symbol. So we say that LMNP is a rhombus. Okay? So let me run through again kind of quickly how I did that. So I graphed all the points, connected them to make my shape, and then I started thinking about the properties, the definitions of the quadrilaterals. Okay, the very first thing you want to do is to find the slope, because that will tell you if you have a parallelogram or a rectangle. We had a parallelogram because our opposite sides had the same slopes. So that told us we had a parallelogram. Nobody was negative reciprocals, so we did not have a rectangle, because a rectangle has four right angles. And to get that you need negative reciprocal slopes, which we didn't have, so we do not have a rectangle. Then I had to double check if all the sides were the same length, because if they were, I could say it's a rhombus. And if it wasn't, I could just stop and go back up and say, hey, my answer is a parallelogram. Okay? But we want to be as specific as possible, so the most specific answer is a rhombus. Okay, I'll flip over. Okay, sorry, had to adjust. These are kind of blanks. I want you to fill them in with me. So we have a kite over here. So let me put our some vertices. We've got J, T, K, and L. Nope, not L. Not L, B. Okay. Now, because it's a kite, I want to go ahead and mark it up as a kite. So if you remember, our kite was marked up kind of like this. The two shorter sides are congruent, the two longer sides are congruent. That's how I'm going to mark it. The two shorter sides are congruent, and the longer sides are congruent. Okay? Now I need some expressions here. So I'm going to let this side here be 2y plus 5. It's going to be x plus 6. This side's going to be 2x plus 4. And then 3x minus 5. Okay? I want you to find the values of all the variables. So we notice we have an x and a y. So we got to find x and y. Well, we know from a kite that these two sides are congruent, and so are these two. But look at this. This has the y and the x up here. That would be not the best way to start is up here. So we're going to start down here where we've got the x's. Okay? So we know that JB is the same length as KB. So we're going to replace those with their expressions. So JB has the 2x plus 4. KB has the 3x minus 5. Now we can solve for x. Okay? In this situation, you've got variables on both sides, which we know we cannot have. We want to have all the variables on one side, everybody else on the other side. So my preference is to move the smaller x. So I'm going to subtract 2x from both sides. So I get x minus 5. Now I need to move this negative 5, so I'm going to add it to make it go away. So I get 9 equals x, or x equals 9. All right? That's one variable. Now I got to go up and do the other side. So now I'm going to look at JT is congruent to KT. Well, that's going to be 2y plus 5 equals x plus 6. Well, I've got two different variables. But luckily, I just found one of them. I just found the x. So I'm going to plug it in over here. So 9 plus 6. What's that give me? That's going to be 15. So I'm going to replace this whole thing with 15. Now I'm going to solve. So subtract 5, 2y equals 10. Divide. I get y to be 5. All right? Find the values of the variables of the isosceles trapezoid, then find the lengths of each side. Okay. Let's mark it up because we know it's an isosceles trapezoid. So we know that by appearance, I'm going to say this is my parallel side, and so is this one. Put my arrows. And then the two that are opposite and non-parallel, so this side and this side, are the same length. So that's how you mark up the isosceles trapezoid. Let me give you some expressions. We're going to let the top be 2x. This over here be 4. This one be 4x plus 3. And this one be 2x plus 2. All right, so now we're going to find x and then find the measures of all the sides. Okay. If I were you all, I would start where I know that something is congruent. So I'm going to start with 4 and this. So I know, based on the isosceles trapezoid definition, that AB is the same thing as DC, the same length. So I'm going to replace them. And we'll solve. I'm going to subtract the 2, subtract the 2, so 2 equals 2x, divide 2, divide 2. Hey, look at that. We get x equals 1. Now, notice everybody that has an x in it, they all have an x and nothing else, so we've got all our work done. So we're going to say AD is 2x, but go ahead and replace it. So 2 times 1 is 2. DC is 2x, which is 1, plus 2, which is 4. BC is 4 times 1 plus 3 is 7. So there you go. Okay, that's all I have. I apologize for the length of the video, but there was a lot involved in this, and I want to make sure you had everything, and that I think I explained it as best as I could. So this video will be attached to the assignment on Google Classroom, and there will also be a homework assignment there, and I will tell you which specific problems you need to do. Okay? All right, that's all I have.